The surface of the table is smoother than this. So if I strike it, it stops over here. If I strike the same, it goes there. So here the frictional force is less and here the frictional force is large. If I strike this magnet, then this stops over here. And if I strike here, it goes. So today we will discuss about the contact force. So contact force is the force which is being applied when the two bodies are in contact. Suppose I am applying the force on this board. So I am applying this force because I am in contact with this board. That's why I am able to apply this force. If I apply a force on this envelope, so unless I strike it, the finger will touch it, the force cannot be applied. So if I just strike it, so as soon as the finger got touched with this envelope, it got forced. Similarly, if I have to pick a book, then if I have to pick this book, so I have to touch it. If I have to draw it from the bag, so I have to pull it. That means unless I touch it, it cannot be pulled. Even it cannot be pushed. When we will put the in the shelf, so then the book is to be pushed, and when it is to be taken away, it is to be pulled. So these all are contact forces. So first of all, the contact force is muscular force. Muscular force. So muscular force means the force applied by a living object, just like human being, just like animals, just like birds, whatever you call it, those living organisms or living objects, they apply the force using their muscles. So when I am lifting this book, I am using my muscles and pushing this book to lift it up. I am pushing it upward. If I have to draw this from the shelf, then I use my muscles to pull it. Similarly, if I have to pick a chair, then I have to use my muscles. Even this bull, it pulls the bullock cart using the muscles. Similarly, the horse pulls the tanga with the help of muscular force. So these are the examples of the muscular force. Now we'll see that when we have to take a book from the bag, then we have to pull the book from the bag. If I have to take this book from the bag, then I will pull this book. If I have to take another book, then I have to again pull this book to take it from the bag. If suppose I have to put it back into the bag, then I have to push it. Just see, I have to push it. I have to keep this book in the bag, then I have to push the book. Similarly, if I have to put this book in the bag, then I have to push the book. And after closing of the school, I have to take my bag from my seat, then I lift it up. After closing the school, if I have to take this bag from my seat, then I have to lift it up. So, to take this book from the bag, I have to pull So when you have to take the book from the bag, you have to pull the book, and when you have to put this book in the bag again, then I have to push it back. So pull, push and lift. I think they are clear. Now we can conclude pulling a book to take it out of the bag is a muscular force. Pushing a book to keep it in the bag is also a muscular force. Force applied by a bull on the bullock cart is muscular force. The force applied by a horse to pull the tanga is a muscular force. A girl helping grandparent, taking them in a wheelchair, she is using her muscular force. Force applied by a rickshaw puller. You use rickshaw puller. Nowadays you are having the battery rickshaw also, but a rickshaw puller uses when you cut the paper, then you are using muscular force. And when a football player kicks a ball, then again he or she is using muscular force. So these are the examples of the muscular force. The second force is, the contact force is frictional force. While you are moving, that time you are using the muscular force, and the force of the retarding force between our shoes and the surface of the ground, a force acts there which is retarding our motion, is called frictional force. So frictional force is a contact force and it applies between the two surfaces when one surface moves on the other surface. So the frictional force is the opposing force, you can say, or a retarding force which comes into play or which acts between the two surfaces when one surface moves on the other surface. Example, the frictional force between the shoes and the ground while we walk. The frictional force is the force between the tires and the ground of an automobile, just like maybe cycle, maybe car, maybe a bus, maybe a truck, or even the train, the wheels and the tracks. But sometimes this frictional force is not because of the hard surfaces or the solid surfaces, but sometimes it is being applied by the liquids also, fluids also. So the frictional force or the retarding force between the boat, surface of the boat and the water is also the retarding force. It is also the frictional force. And similarly, air friction is also there. While moving a train or a plane in the air, that train is moving on the track and the air is gushing out, or you can say the train is moving, so the air is blowing behind. So there is an air friction between the train, even the car, and that's why you have seen that they are streamlined. Then to reduce this friction, water friction, the water animals have a shape, streamlined shape. Just see the shark, just see the dolphin, they will be always pointed, so that, and that's why the ship and the boats are designed in this manner to reduce this force. So the force of air friction is the friction between the surface of the plane and the train with the air. Similarly, if you just shift a table, just pull or push a table, then there is a frictional force between the table and the floor. Similarly, if you see, during winter we just rub our hands, the palm. So the frictional force between the palms is a force which is frictional force, and due to that friction the heat is generated. Similarly, when a ball is just rolling down, you have I have also the activities also. With the help of those activities, the all examples will be the concepts will be cleared. When you kick a ball, after some time this ball comes to rest. Why it comes to rest? Because of the friction between the surface of the ball and the ground. When you pedal a cycle and once you stop the pedaling the cycle, after some time the cycle stops. Similarly is with the case of the car, with the case of the bus. So that means this frictional force is always in the opposite direction of the motion. If this is moving this way, so the frictional force will be in the opposite direction, and so this body will stop after some time if you will not apply continuously the force on this. So frictional force depends on the roughness between the two surfaces. That will be very clear with the help of the activity I'll show you. Frictional force is always taking place between the two surfaces when one rolls or slides. That means when one moves on the other surface. This frictional force always retard. It is opposing in nature, so it will slow down the speed. It will stop the motion. It will reduce the speed of the motion of the body. And this frictional force is depending on the nature of the surfaces. That means if the surface is more rough, so the frictional force will be more. This all thing will be clear with the activities. This, yes, it is kept to be in mind. And suppose you are moving and there is no friction, so can you stop at your home? You cannot. So this is a necessary evil. It is an evil. It creates wear and tear. Your tire of the car or the cycle is torn because of the friction, and then you have to replace it. So it is a bad thing, but it is a necessary evil. That's why, because unless you apply the brake or the brake is applicable, then you cannot stop. The accident will take place otherwise. So when you are applying the brake, that means you are using friction. So this is our servant, you can say, to safeguard you, and this is necessary. That's why it is called necessary evil, because it caused something in the form of wear and tear. And this friction force, of course, is very, very important. The frictional force, you can say the example is the friction force between the ground and the shoes while you are walking or we are walking. The drag between the tires and the road, their frictional force between water and the boat surface. Similarly, air friction force between the train and the air. Similarly, air friction in case of the aeroplane, or you can say the frictional force stops the ball. When a ball is moving, then it is stopped. When you throw something or you slide something, then after some time it stops. The car also stops if you don't apply the accelerator. Then after some time it will stop. Even your cycle will stop if you stop the pedaling. And the rubbing of the palm, is also a frictional force. So now we'll have the contact forces. This frictional force is naturally changing the state because it reduces the friction. Now we have the non-contact force. Non-contact force are those forces which are applied between the two objects without actually in contact there. They are not to be in contact. So we can have gravitational force for this. So gravitational force is the force between the earth and every object. Similarly, in the whole universe, two objects are always attracting each other. This gravitational force is always attractive. So that is why each and every object falls towards the earth, because earth applies the gravitational force. So this gravitational force is attractive in nature, and because of that all the bodies are falling towards each other. Even the tides are there due to the force of attraction between the earth and the moon. Frictional force. Now we will have a frictional force over here. Just see this surface, this table ki surface, the surface of the table is smoother than this. So if I strike it, it stops over here. If I strike the same, it goes there. So here the frictional force is less, and here the frictional force is large. If I strike this magnet, then this stops over here. If I strike here, it goes a little longer. That means it proves that here the frictional force between this surface and this surface is more, and here this is surface, so it's less, because the distance cover is more and here the distance cover is less. With the same force, it is moving more distance. Similarly here, let's see, this is over here and this is like this, so it moves a longer distance. With this book, if I push this way, then it goes a longer. If I push it to this, so it goes longer. So this surface is smooth. So if the surface is smooth, then its frictional force is less. It will offer less frictional force. If the surface is smooth, rough, so it will offer greatest frictional force. Gharshan ball, here, if you just place it here, it will move, and you can see and you can judge that angle is more or less. So here you can see this angle is here. If I take it here, it is something smooth. Here the more surface roughness is there. So here you will find this angle, this light over here. Now see the case of the book. So the book starts sliding at this almost the same, a little higher than that of the plastic. Yes, a little higher. And now this block, so here it is at more steeper. So here again, So the angle for this block is the maximum. So the frictional force between the surface of the block and the ply is maximum. And for this brass surface and this ply surface, the angle was the minimum. So the frictional force was the minimum.